The last section of Unit 1 is on dimensional analysis. Dimensional analysis is a systematic approach to problem solving that uses conversion factors to move or convert from one unit to another. Okay, so again, giving you a definition without any sort of context might make it a little bit confusing. Don't worry, we're going to do several examples together. A conversion factor is basically a ratio of equivalent values having different units. So an example here of a conversion factor might be something like 1 minute is the same thing as 60 seconds. We would agree that those are the same amount of time, even though the unit is different. Or you might say, 1 foot is 12 inches. Okay, or since we're starting to use the metric system, you might say 1,000 meters is the same as 1 kilometer. All right, but basically, they're a ratio where the numbers are the same. And how we're going to write these is, say, 1 minute over 60 seconds is the same thing as 60 seconds over 1 minute. We can write it either way because it's the same thing. It's like writing 1 over 1. Okay, they're the same value. They mean the same thing. Okay, you could write 1 foot is the same thing as 12 inches, or you could say 12 inches is the same thing as 1 foot. Either way, no matter what unit you put on the top or the bottom, it doesn't matter because the conversion is exactly the same, right? 1,000 meters is the same thing as 1 kilometer, or 1 kilometer is the same thing as 1,000 meters. Okay, those are all conversion factors. Okay, so we're going to get very good at writing these. In reality, you've done problems like this before. You didn't just necessarily know what you were doing. And we're going to start off with a pretty easy one. And you're probably wondering, why are we even bothering doing a problem like this? And the answer is, what we're trying to get here is the critical thinking to work through this. What we're going to try to do is get rid of units and work to a final answer. We're trying to cancel out units, okay? And if you can do this, you're going to do well in chemistry. Okay, and why do we learn this even if you're never going to take another chemistry class in your life? It's because at some point, when you have to figure out how much of something you need to purchase, or how much it's going to cost you, how often you need to order something, or how much to get, you can solve these problems without an equation because you can think through equivalent values. So we're going to start here with an example. You've probably done a problem like this, in grade school math, and you could think through without even having to write stuff down. We're going to do this and write down all of our possible conversion factors and then solve this thing. Okay, so it says, you and 23 friends are going to have a pizza party. You can each eat 3 slices of pizza. Each pizza has 8 slices. How many pizzas do you need to order to feed your friends? Okay, so what we're going to do before we even set this up is let's come up with some equivalent values here. Each person can eat 3 slices of pizza. So we'll say that one person, okay, can eat 3 slices. We can also say that 3 slices is the same thing as one person. All right, is what that's telling us. Each pizza has 8 slices. So it sounds like we could also make a conversion factor of 1 pizza is the same thing as 8 slices, or 8 slices is the same thing as 1 pizza. How many pizzas do you need to feed your friends? Okay, so you and 23 friends, so 24 people. All right, so what we want to do is get rid of units. And I want to show you a little trick. If you've never noticed this before, never done this before, a lot of chemistry and a lot of just math and science problems in general, if you can understand how to eliminate units and how units work, you may even forget the equation to a problem but be able to solve it. All right, so let's say I had, we're just going to use numbers here. Let's say I had 2 times 3 times 4 times 5, all divided by 2 times 5, right? And right now you're looking at this going, okay, I know enough algebra to know that this 2 on the top will get canceled by the 2 on the bottom. This 5 on the top will get canceled by this 5 on the bottom. And what I'm left with here is just 3 times 4, right? And so the answer to this would simply just be 12. And you were able to do that because you canceled numbers. Ones on the top would cancel by the ones on the bottom. They just had to be the same thing, okay? Well, let's say I had this, with variables. I have x times y times z divided by z. Well, then same thing, right? You're just going to cancel your z units, and you'd be left with, let's change this back to black. There we go. You'd be left with x times y, right? Okay. You can do the same thing with units. The numbers aren't going to cancel, but now the units will cancel. Let's say I have, let's just make something up here, feet times seconds times, what the heck, amps. We'll just make something up, right? We'll use capital A for it. Totally meaningless unit divided by seconds times amps. All right? The numbers wouldn't cancel, but the units would cancel, and I'd be left with here from this problem, seconds would cancel, amps would cancel. I'd just be left with some number, right? Whatever the number would be, feet. So let's take a look at this problem. I've got 24 people is what I'm starting with. There's no equivalence here. There's not like a conversion factor with people. So just 24, right? That's what we're going to start with, right? We're going to use these conversion factors to get us there. Well, persons and people we're going to say are the same unit. If I have people on the top here, I'm going to need people on the bottom, just like we were showing you down here, to cancel that out. So what I want to do is write this with the unit of, we'll say people, okay, or persons in this case. And then I look up here to find a conversion factor with people or persons on the bottom. And I'm going to pick this one, okay? So that's 1, and then on the top would be 3 slices, all right? And as we do this, my unit of people cancels. The 24 doesn't cancel, the 1 doesn't cancel, but my unit does, okay? Just like we were showing you over here. So now I've got slices on the top. And let's get out of using red. Okay, there we go. So times. Now to get rid of slices, since slices is on the top here, I need it on the bottom here. Okay. And then I look for, all right, which one of these has, I've already used these conversion factors, right? So I shouldn't need them again. Okay, now I'm looking over here at what I have left. This one has slices on the bottom, so I'm going to pick this one. Okay. We've got 1 pizza is the same thing as 8 slices, right? And that's all the conversion factors I have. Plus, if we look at what happens here, slices cancel, which leaves me with a unit of pizzas, and that's what the question's asking about, right? How many pizzas do you need to feed your friends? Well, I should end up with a unit of pizzas, okay? Now, mathematically, the numbers don't cancel. This is still going to be 24 times, well, 3 over 1 is 3, and then times 1/8 is the same thing as divided by 8. So it's going to be 24 times 3 divided by 8. Okay, let's see what that gives us. 24 times 3 divided by 8. And that works out to a really convenient number of, let's change it to black here, 9 pizzas. Okay, so that's how we would solve this. We kind of work our way through these conversion factors, make sure we pick the right ones. All right, we picked the 2 correct ones here. And once we've used them all up, we make sure that our final unit matches what the question was asking about. But the big takeaway here is to notice how units cancel. Okay, another one. This is when it gets a little bit more complicated. And again, you're wondering, why are we doing this in chemistry? It's because there are skills to be learned from this in the adult world, things that you'll use beyond just chemistry. So even if you never touch chemistry again in any of your classes, it's still important to learn this, because at some point, if you own a business or you're working a job, you'll need to be able to have these skills to think through what you're doing. So this says you are the head chef at a restaurant. For breakfast, omelets require 3 eggs each. On an average day, 128 guests will order an omelet. In 1 week, how many cartons of eggs will you need to purchase? So we're going to have to come up with several conversion factors here to get us to a final solution. I've gone ahead and just given us the start point. I get 128 guests per day, okay? And we're going to work our way to a final unit. So sometimes it's helpful to write down just what I'm trying to get to. How many cartons of eggs will you need to purchase in 1 week? Okay, so what I'm trying to get to here is a final unit, okay, of cartons per week, right? That's what I'm trying to get to. I need to move away from this guests per day to cartons per week, and I need to use the information in the problem here to get us there. So let's just go sentence by sentence. Omelets require 3 eggs each. Okay, so that sounds like I could write 1 omelet is the same thing as 3 eggs, okay, or, whoops, 3 eggs is the same thing as 1 omelet. And so there's the first one we got. On an average day, 128 guests will order an omelet. So we've got this. However, there's kind of a small one missing here. We would say that one guest is the same as one omelet because that's how many each of them would order. And even though it's a 1/1 ratio, it's important to do this so that we can cancel units. I got to get rid of this guess and start working my way towards cartons. So we're going to write down this unit. In 1 week, how many cartons of eggs will you need to purchase? Okay, so there's two things going on here. I need the conversion from days into weeks, right? So we've got 1 week is the same thing as 7 days. Okay, or 7 days is the same as 1 week. And then lastly, how many cartons of eggs we need to purchase? Well, if you've ever gone to the grocery store, you know that eggs are sold by the dozen. So we'll say that 12 eggs is the same thing as 1 carton of eggs. Okay, or we can write that in reverse as well. Now it's just a matter of using these. I know there's, let's see, 1, 2, 3, 4 of them to get us to an answer. We just need to get away from these units here and into a final one. So as long as we work away from these two, we're always going to be going in the correct direction. So let's first get rid of this guests, right? Guests are on top here. So it means I need to pick a conversion with guests on the bottom. Well, if we go along down here, the only one with guests on the bottom is this guy. Okay, so we're going to have 1 omelet is the same thing as 1 guest. Now, all right, I have used up that conversion factor. I don't need to come back to it. Okay. All right, so that one's good to go. Now, and if we should also be canceling things as we go. Guests are gone. So now I have a unit of omelets per day, right? Omelets over days. I can then get rid of days and get immediately to weeks. So that would get me all the way to the correct final unit of time. So let's go ahead and do that. All right, if days is on the bottom here, on the conversion factor, it needs to be on the top. So we'll put days up here and week down here. And we got to find where that one is. Hopefully you know what that conversion factor is already. We want this one, okay? And we're going to put the 7 here and the 1 here. And that's going to use up this conversion factor. Now we've only got 2 more that we've got to work with. And let's go ahead and also cancel out units while we're at it here. Oops, let's see. That like that. We want this one. There we go. Days is going to cancel. Okay, so now if I stop the problem, I have omelets per week, which is getting us close. This unit's already correct. And notice we're trying to get to cartons per week. So I already have weeks on the bottom. I don't need to do anything else to that. Now I need to get rid of omelets and eventually wind up at cartons. So let's look for one that's got omelets on the top of our remaining 4. It's going to be this one right here. Okay, so we'll go ahead and give that one a check mark. Whoops, move the whole screen. Not what I wanted. There we go. So we want that one. We're going to multiply that times. Okay, so 1 omelet's going to be on the bottom. And 3 eggs is going to be on the top. And if we cancel stuff out, omelets cancels. And if I stop the problem here, I'd have eggs over week. Okay, eggs per week. We're going to go ahead and also circle this one just to indicate that we have gotten that one done as well. And now we're on to the final one, which should get us out of eggs and into cartons. So if eggs is on the top here, I need to pick the one with eggs on the bottom of my conversion factors. That's going to be the second one. All right, so now we've used all of our conversion factors. And I want eggs on the bottom, so I've got 12 eggs down here is 1 carton. Okay. So then I can go ahead and cross off eggs. Now, if we look at all of my units that have canceled, those are gone. Those are gone. Weeks is on the bottom. These are both gone. Cartons is on the top. I have cartons over weeks, which is the final unit we want. Now, when we type this into a calculator, we don't cancel the numbers. It's still 128 times 1 times 7 times 3 divided by 12, or times 112, however you want to look at it. 128 times 1 times 7 times 3 divided by 12. Okay, let's see what that gets us. 128 times 7 times 3 divided by 12. Okay, this gives us a final answer of 224 cartons per week. Now, if you wanted to go a step further, right, if you actually like own the restaurant and were worried about, the numbers, you can figure, okay, well, how much does one carton of eggs cost me? Okay, how much am I spending a week ordering eggs? How much do I need to charge to make money on an omelet? So you can do all kinds of math with this. We didn't have an equation, right? There was no set equation for this. We just had to sit here and play with the units, canceling things out until we got to this number. But that's why this is useful. If we can critically think our way through this, we can get an answer, and then we can do even more with that answer. Like I said, you can figure out how much are you spending ordering eggs every week? How much do I need to charge per omelet so that I'm making enough money to justify what I'm doing here? Okay, that's why this is important. Even if we're not doing chemistry, we got to learn how to do this. Okay, I want you to try this last one on your own. And then I'll walk through it after you've tried it and given your answer, just to show you how to do it. It says the world's fastest ant moves at 855 millimeters per second. How fast is it moving in miles per hour? And it gives us a conversion of miles to feet, a conversion of inches to centimeters, and a conversion of centimeters to millimeters. Okay, so I want you to go ahead and try this, and then I'll solve it for you. Okay, so I've gone ahead and written out all of the conversion factors possible here. We got 1, 2, 3, 4, 5, 6 that we're going to need to get from this millimeters per second into miles per hour. And down below what I've done is I've taken our measurement, which what we're going to start with, 855 millimeters per second, and I've gone ahead and pre-filled this in just to make sure I have enough space to do all of it. But we're going to get out of seconds first and into hours, because this is the unit we're aiming for, miles per hour. So I need seconds over minutes. That's going to be this one right here. So I have 60 seconds for 1 minute. I need minutes over hours. That's going to be right here, 60 minutes over 1 hour. Okay. I then need the centimeters to millimeters conversion. That's right here. I need the centimeters on the top, so it's 1 over 10. And then I need to get rid of centimeters, so centimeters on the bottom. I need the inches over centimeters conversion. That's 1 over 2.54. And then I need the feet to inches, because then I can get myself to the miles. So some of these you have to kind of think on your own. They're not all just given to you. Some of these you have to just know. Feet per inch, that's 1 over 12. Okay. And then times, and then miles per feet, miles over feet. So this is going to be 1 mile over 5,280 feet. Then we're going to go ahead and plug all this into the calculator here in a moment. But first, let's just walk through and see how all these units cancel. Seconds cancels. Minutes cancels. Hours is good because that's the unit we want on the bottom. So we're not going to change that anymore. Now I'm getting rid of millimeters, notice. Okay. So millimeters cancels. Centimeters cancels. Inches cancel. Feet cancels. The only units I'm left with when this whole thing is done is miles over hours. Miles per hour. Okay. So now we just need to plug it into a calculator. We have 855 times 60 times 60 divided by 10 divided by 2.54 divided by 12 divided by 5,280. And we get from this, we're going to use 3 significant figures because there's 3 right here. You're like, well, what's going on here with all these? These are exact values, so we are not rounding with significant figure rules on any of these numbers here in the middle. We're only going off of this first number. So we're going to use 3 significant figures in an answer. This is 1.91 miles per hour. So it's going just under 2 miles an hour as the world's fastest ant.